For our last section of this unit, we're looking at section 4 on vectors and dot products. Okay? We mentioned earlier that anytime you're dealing with a new construct like vectors are, they're not just real numbers, it's a new construct, it's something that we're dealing with that's a little bit different. We have to define different operations. That's why we defined what addition was. We defined what scalar multiplication was. All right? So, here we're actually defining a second type of multiplication. Okay? And that is a dot product. There's actually 3 types of multiplication when it comes to vectors. There's the scalar multiplication that we already looked at. There's the dot product that we're going to look at today. And then there's a cross product that we're actually not going to work with this year. But let's look at what this dot product is. And it's important here that we not only recognize how to do it, but we remember what it gives us. Okay? When we did scalar multiplication, our answer ended up being what? A vector. Okay? A vector. We were multiplying a vector by a scalar, and we ended up with a vector. Here, we're going to multiply 2 vectors together, but look at what we're going to end up with. We're going to end up with a scalar quantity. All right? Here's our definition for a dot product. If U has the components U1, U2, and V has the components V1, V2, then the dot product, and the way you read this is U dot V, okay, U dot V is how we read this, is the product of the horizontal components plus the product of the vertical components. And again, that will give you a scalar. Okay? So let's practice using this a little bit. Okay? Let's say that we have these 2 vectors here, 3, 5, and 6, negative 2. Alright, so if I'm finding our dot product, I'm going to take 3 times the 6, the product of the horizontal components, plus 5 times the negative 2. Okay? So 3 times 6 is 18. 5 times negative 2 is a minus 10. So that equals 8. The dot product equals 8. Let's look at it again. Here we have the vector 3, 9 times the vector negative 8, negative 4. Finding the dot product. Okay? So we're going to do the horizontal components, 3 times the negative 8, plus the product of the vertical components, 9 times negative 4. Okay? So we've got a negative 24 minus 36, which is a negative 60. Okay? So not too bad, is it?
No.
Okay? Not too bad. You just got to remember the formula. Alright? Let's try these 2 more. Okay? In fact, you try them on your own. I'm mixing up the notation here too a little bit so you don't get too used to just using one.
I don't think we've ever used the notation in the 4th problem.
I've shown it to you. We haven't necessarily used it all that much yet.
Do you need to put the dot, or can you just kind of put them next to each other and then it will be like inferred that it's dot?
You should put the dot because there are two different types of multiplication when it comes to multiplying two vectors together. You have the dot product and the cross product, so you want to put the dot there. Okay, does someone want to come show us how to do 4i plus 6j dot negative 7i plus j? All right.
I want to redeem my other less fortunate grade.
All right, good.
Does that work or not?
You just there you go. Now it'll work.
Oh, okay, I can't use this. I have to use this. Something wrong? I don't know. Am I good?
Oh, be confident. Come on.
Blocking out the haters. Yeah.
All right, what do you guys think?
Oh, come on.
Please excuse the interruption. Luis Melo Lima to the health office.
Okay, he's on his way.
Should I do my things?
No, I think we're supposed to get your eye drops again. The health office.
Well, like, okay. Never mind.
All right, good. So 4 times negative 7 is negative 28. 6 times 1 is 6. So you add them together and get negative 22. All right, good, good. How about the last one? Would someone like to come show us this one?
I'll do it.
All right, Matthew.
I don't know we're so loud when we use it and you're so quiet.
You use your fingers?
You can. If you put the marker down, it'll let you use your
Oh,
finger.
I thought you had to pick up the marker to use your finger. Because, like, at my Hebrew school, with the whiteboard, what you have to do is you have to pick up the marker so it senses that the marker's gone and then goes, oh, it must be marker. But no, you trick it. It's your finger. Negative and SN.
All right, good, good. Negative 5 times 11 is negative 55. 6 times 12 is 72. Add those together and we get 17, okay? Good, good. Now, the dot product by itself is not incredibly exciting, all right? However, it is used for a few different things, okay? The applications here are really where things get interesting, okay? So, we also have some various properties that are related to the dot product. I want to run through these just, kind of quickly here first, and then we'll look at an application. The dot product. All right, a couple things about the dot product. First of all, u dot v equals v dot u. In other words, the dot product is commutative. Okay, order does not matter. And that's important. Okay. Also, what's this right here?
0.
The zero vector, right? So if I do the dot product of the zero vector with any other vector, I get 0. Okay? This one's kind of interesting. Number 3. Number 3, we have u dot, the quantity of v plus w. So here we have some vector addition. And if we're doing the dot product, we can distribute that u into both of them. Okay, so it's u dot v plus u dot w. Okay, so the distributive property works. Okay, this one's kind of an interesting one. If you dot a vector with itself, which, by the way, we do not put v squared here, okay? You dot a vector with itself, you actually end up getting the magnitude squared, okay? If you think about that one, it makes sense. If I have a vector v that is ab, if I do ab dot ab, a times a is a squared plus b squared.
C squared.
Yeah. Okay.
No,
Well-
but it cancels out the square root and the magnitude.
It does. Okay. The magnitude of v is the square root of a squared plus b squared. But if we square that, okay, we get this. All right. So actually, we just proved that property. Okay, the dot product of a vector with itself is the magnitude squared. Okay? And then number five, if you have a constant times a dot product, okay, you can either do the dot product first and then multiply by the constant, that's what this is saying, or you can multiply either one of the two vectors by the constant and then do the dot product. And I put here, I put the little similar to sign here. This is similar to the associative property. It's not exactly the same, but you can kind of think of it almost like an associative property. We can put the c with either one of the two vectors, or we can do the dot product first and then multiply by the constant. Okay? So those are some properties of the dot product.
So the constant doesn't get distributed.
No, it's not distributed because if you think about it, there are different types of multiplication, but it is still all multiplication. Here we had addition inside the parentheses, so we did distribute there. Okay? So if we think through this, all right, if I'm doing this, okay, u dot v dot w, okay, u dot v dot w, I want to do, here it's like the associative property, okay, I want to do u dot v first, all right, so I get u dot v is a negative 2 minus 12, okay, so u dot v is negative 2 minus 12, so that's a negative 14. So now I have negative 14 times vector w. Notice here I didn't need a dot because this is a constant times a vector.
Wait, you did u times v?
I did u dot v, which gives me a scalar, or a constant, and now I'm multiplying that by vector w, which was 1, negative 2.
How did I give you a constant? I don't understand that part.
It's a dot product. A dot product always gives you a scalar. or a constant.
Oh, okay.
Okay.
So wait, go back for a second. So you got the -2 negative. Is it -2 minus 12 or -2?
Yeah, -2 minus 12. You don't need the parentheses there. But -2 minus 12 would be -14.
Okay.
Let me get rid of the parentheses. I think that may be what's confusing.
Nah, I'm just a little lost about like how like you have U with like not like coordinate points I guess, and then the number.
Well, U and V are right here.
Yeah.
Okay, so -1 times 2 is -2. 3 times -4 is -12.
Okay.
So -2 minus 12 is -14.
I get that.
Now we're multiplying that by vector V, vector W, sorry. We have 1, -2. So we get a -14, positive 28. Okay? Okay?
Can I go to the restroom?
So then is that your final answer?
Okay, yeah, that's our final answer. That's U dot V times W. Okay. Now here, I have U dot 2V. So guess what I'm going to do? I already found U dot V over here, right? So I'm going to use this property, number 5 up here, to rewrite this as 2 times U dot V. See how we can do that? It's just like this. A constant times a vector V. I'm going to pull it outside and do the dot product first. Well, I already know U dot V is -14. So 2 times -14 is a -28. Okay? So you see how you can use these properties to kind of save you some work. We don't have to do the same thing again. Okay? Here we are given this a statement. The dot product of U with itself is 5. In other words, U dot U equals 5. So the question is, what is the magnitude of U? Root 5, yeah. This is, using the property above, the magnitude squared. So the magnitude of U must be the square root of 5. All right. Any questions about our properties or? All right. So here's where we actually can start using this. The angle between vectors. You might remember yesterday we did a problem similar to this, okay? In fact, let's go back and look at it. We had, nope, not that one. Oh, where was it here? Was that on the original homework? Or was it on the previous day? I think it was on the previous day here. Where we had to find the angle between the vectors. Oh, no, it was yesterday. Wait. Oh, why can I not find this? Oh no, this was it. Okay, this was it. I wanted to find an angle between two vectors. Okay? So we had this 45-pound vector, and we had this 60-pound vector. That's the 60, and here's the 45. And we wanted to find the angle between the two vectors. And in order to do that, we had to kind of translate this over, so we were doing vector addition. Okay? Now, the angle between two vectors, we couldn't have done what we're about to do in this setting because we didn't have enough information. Alright? But finding the angle between two vectors is actually, a common task. And one thing that we can do if we know the vectors in component form is we can actually use this formula here. Okay? Now, you'll notice here, they actually define something for us. When we draw two vectors from the same point, the vector that connects the two is v minus u. Okay? So here we have vector u. Here we have vector v. If we connect u over to v, going this direction, this vector here is actually v minus u. Okay? Now, you don't necessarily have to remember that in order to use our formula, but notice the angle here we're trying to find. We're trying to find this angle between the two vectors. A couple of things here that you need to understand. First of all, the angle that you're going to find will always be less than 180 degrees. Okay, or I should say less than or equal to 180 degrees. All right, theta will always be between 0 and 180 degrees. Okay? The reason for that is, if you wanted this angle, you could very easily get it by then just subtracting from 360. Okay? But when we're saying between, we're looking at the smaller angle between the two. Okay? Not outside. But here's our formula. The cosine of theta equals the dot product over the product of the magnitudes. Okay? This is a formula you need to know. Alright, cosine of theta, the angle between two vectors, is equal to the dot product of the two vectors divided by the product of the magnitudes. So, for example, here we have the vector u that is 4, 3, and I've drawn it here for you. The vector v is the vector 3, 5. Okay, so I've drawn that. We want to find theta, the angle between these two vectors. So, we need to find three things first before we can use our formula. Our formula calls for the dot product and both of the magnitudes. So we need to find each of those first. Okay? So what's u dot v?
12 plus 15.
Good. 12 plus 15. So we've got 27. Okay? 4 times 3 is 12. 3 times 5 is 15. So we've got 27. Okay. What's the magnitude for u?
Square root of 16.
It's 5, yeah. Square root of 9 plus 16, that's 25, so our magnitude is 5. Okay? And then what's the magnitude of v here?
Square root of 34.
Square root of 9 plus 25, which is 34. Now, sorry, 25, which equals the square root of 34. That's 2 times 17, so that doesn't simplify at all. You'll just leave it as square root of 34. Alright, don't punch in decimals here. We're not going to round anything till we get our final answer. Okay? So now we can use our formula. Alright? The formula calls again for the dot product over the product of the magnitudes. So we know that cosine of theta equals the dot product 27 over the product of the magnitudes 5 times the square root of 34. Okay? So how are we finding theta here?
Multiply root 34 over 34.
Inverse cosine.
We don't have to do that.
You just take the
To solve for theta,
Inverse.
inverse cosine. Alright, so theta is the inverse cosine of 27 over 5 root 34. Be careful with your parentheses on your calculator. Okay? Make sure you're in degrees. So we'll do these in degrees as well. What do we end up with for theta then?
22.17 degrees.
Is that correct? Anyone checking? You should be. You got that too, Liam? Okay, Tyler? Alright? Alright, so 22.17 degrees. Does that make sense based on our diagram?
Yeah.
Yeah, that makes sense. Okay? Now, I want you to think about this. Okay, think about what you know about cosine. And let's think about our signs as well. Signs as in positive and negative. Okay? Okay, cosine's positive in the first and fourth quadrant. Since our theta is always going to be between 0 and 180, that means if we have a positive cosine, we're going to end up with an acute angle, first quadrant, right? What's going to make the cosine be positive? Looking at our formula and everything.
When the sine's positive?
Well, yeah, when the sign is positive. Can any of those, the dot products or the magnitudes, ever be negative?
Well, both of them are.
The magnitudes cannot,
But the dot product can.
but the dot product can. Alright? And I point that out here, guys, because your dot product, if you find that first, that'll tell you a little bit about your angle. And in some cases, that'll actually tell you your answer without even having to get the magnitudes. Okay? Let's think about this. If your dot product is positive, and we know the magnitudes are always positive, cosine will be positive. So that means our angle is going to be first quadrant, right? What happens if our dot product is negative?
It'll be in the second one.
We'll get in the second quadrant, okay? What's the only other possibility?
0 or 180.
Wait, what?
0 or 180.
What's 0 or 180?
Angle.
Well, 0 would be if it's positive, because positive 1, cosine being positive 1 would give us 0 degrees. If it were negative 1, we would have 180 degrees, okay? But still we've got positive and negative. What's the only other possibility? 90 degrees,
It will be 0,
what will be 0?
like the final result.
Okay, the whole result will,
Oh,
but
so
what
it's
will
the
make
dot
that?
product
the cosine, you know.
There we go. If the cosine is 0, we have 90 degrees. What's going to make it equal 0? If the dot product is 0, okay? The dot product is 0, and we have a term for that. We have a term, these vectors are orthogonal, okay? That means the angle between them is 90 degrees, okay? So look, how does this relate to the angle between vectors? If u dot v I'm gonna make a little table here. Let me scooch this down. Oh, it's all in one thing. Okay? If u dot v has 3 possibilities, it could be positive, 0, or negative. That's going to mean different things for our angles. Theta will then be, if it's positive, what do we say?
First quadrant.
It's going to be first quadrant. So it's going to be between 0 degrees and less than 90 degrees. So I'll use a half open interval there. If the dot product equals 0, our angle is 90 degrees exactly. And if our dot product is negative,
90 and
90 to 100.
good, it's bigger than 90 up to 180 degrees.
does it include 180? Like, can you have an angle?
It could be. Yeah, they could be going exactly the opposite directions, which that's not quite, but you get the idea. But they're the dot product, u dot v would be negative, and there it would end up being the dot product would equal the opposite of the product of the magnitudes. So you'd have cosine theta equals a -1. Okay?